Alright, let's take a look at another optimization problem. At G&W Industries, it has been shown that the number of gizmos an employee can produce each day can be represented by the equation n of t is equal to negative 0.05 t squared plus 3t plus 5, where t is the number of years of experience the employee has, and t is greater or equal to 0 but less than or equal to 40. How many years of experience does it take to achieve maximum productivity? So to find maximum productivity, we have n of t. I'm going to find the first derivative, so I'm going to do n prime of t, right? And you get the derivative with respect to t, and t is the number of years, negative 0.05 t squared plus 3t plus 5. Off the bat, you can notice here that this is a quadratic equation, and because it's in the form of ax squared plus bx plus c, a is less than 0. It is concave down, and quadratic should have one extrema, right? One less. They should only have one term. So derivative function here is basically negative 0.1 t plus 3. So this is n prime of t. And then we'll let n prime of t equal 0 to find the extrema. So you get negative 0.1 t plus 3 is equal to 0. I'm going to move 3 to the other side, so you get a negative 0.1 t is equal to negative 3. Solve for t, I'm going to divide by 0.1. I'm going to do the same thing to this side. Cancels out. T is equal to 30. Okay, so when t is equal to 30 years, we should get maximum productivity. And the maximum productivity, if you want to figure out how many gizmos the employee can produce each day, you just do n of 30. Okay, so you get negative 0.05 times 30 squared plus 30 times, plus 3 times 30 plus 5, and n of 30 will tell you what your maximum productivity is going to be, right? So I'm just going to crunch that out, and that gave me 50, right? So therefore it takes 30 years to achieve maximum productivity, and the maximum productivity appears to be to produce 50 gizmos a day.